Welcome to your worst nightmare, AP Calculus.
Bum, bum, bum. Alright, class, take your seats. Today, we're going to be moving on from limits and learning a new topic. This topic is called derivatives. We will be going over this for multiple weeks as it is a very long and extensive topic. So, to start it out with, derivatives. Our first topic in derivatives will be the power rule. So, with the power rule, if I gave you an example such as 4x squared, and I asked you to take the derivative of that, how would you guys go about doing that?
I don't know.
All right, I figured as such. So essentially what we do is we acknowledge our coefficient and our power. So we have the x to the power of 2. What we're going to want to do is multiply that by the coefficient and reduce the power by 1. So if we were to do that, this would turn out to be 2 times 4, which is going to be 8, and then reduce the power by 1, which would be x to the first, or we can just leave it as x. So that would just be our answer, as simple as that. Okay, so now that I've taught you guys how to do one example using the power rule, I'm going to let you guys try it on your own. So I'm going to give you the function 5x cubed. So how would you take the derivative of that, Caesar?
Wouldn't you bring the 3 down, multiply it with the 5, so that would be 15, and then reduce the power by 1, so that would be x to the second, so it would initially be 15x squared?
That's correct. So as we can see, we would multiply 3 by 5, get 15, reduce the power, 15x squared is our answer. All right, so now that we've covered the power rule, I want to move on to another topic, a little bit more challenging, but essentially the same concept. We're going to move on to the product/quotient rule. So, what we do in the product rule is u prime times v plus v prime times u. So, what that's talking about, well, let me give you an example. We have, let's say, the quantity x squared plus 1 times the quantity 2x squared plus 2. All right, so what we would do with this example is this would be our u, and this would be our v. So let's make a note of that. So first we would take the derivative of u. So we would get 2x, and the 1 would disappear. And we would then multiply it by our original v, which would be 2x squared plus 2. And then we would add all of that to the derivative of v, which would then be, let's do the power there, 4x to the first power, so it would be 4x, and the 2 would disappear, as it doesn't have a variable attached to it. And then we would multiply that the initial quantity of u, which would be x squared plus 1. We've now essentially taken our derivative of this function. All we need to do is simplify it to pretty it up. So what we would do is distribute the 2x into this quantity and distribute the 4x into this quantity and then add them. So let's do that. So we would do 2x times 2x squared, which would be 4x cubed. 2x plus 2, or 2x times 2 would be 4x. And then we would add that to 4x times x squared, which would be 4x cubed. And then 4x times 1, which would just be plus 4x. So now what we have with this
Combine like terms.
is, yes, combine like terms. So we would do 4x cubed plus 4x cubed. So simple enough, would be 8x cubed, and then 4x plus 4x, and that would give us 8x. And then if we wanted to, we could always factor out an 8 and have it at an 8x actually, and factor out an 8x and have x squared plus 1, and then just multiply by 8x, and then that would be
Well, why
our
couldn't you
derivative.
just take the derivative of the first one and the derivative of the second one and multiply them together? Wouldn't that do the same thing?
Well, that is the intuitive way to think about it, given only the concept of the power rule. But that's why I'm introducing you to the product rule, because in such a case where you're multiplying two quantities together, you have to use this exact formula.
So
Doing
that
it
way
that
it
way
wouldn't
would be
work?
incorrect. No, it would not work. But good observation. So now we're going to move on to, I don't have much space here, so we'll move on to the quotient rule on another separate piece of
There's
paper.
another rule.
Yes, it is another subtopic of the derivative. So now we're going to move on to the quotient rule. So we have our function x squared plus 4 over x plus 5. So what we would do with this is use the quotient rule formula, which is equal to u prime times v minus v prime times u all over v squared. And v is equal to our bottom quantity, and u is equal to our top quantity. So v is equal to x plus 5, and u is equal to x squared plus 4. So what we're going to do is take the derivative of u, which would be 2x, and the constant will go away. Then multiply that by our original v, which would be x plus 5. Then we are going to subtract v prime, which would then just be 1. I'll put parentheses here. 1 times our original u, which would be x squared plus 4. So, and then also put all of that over v squared, which would be x plus 5 squared. So now all we have to do is simplify this. So we'll distribute the 2x and 2x plus 5, and we will get 2x squared plus 10x. And then we will subtract that from, we would distribute this, it would just be 1, so it would be subtracted from x squared plus 4. So we would then have x plus 5 squared on the bottom. So we distribute this negative, so we would have 2x squared plus 10x minus x squared minus 4 over x plus 5 squared. And then we'll finally get to the final simplification to get x squared plus 10x minus 4 over x plus 5 squared, and we do not need to simplify this any further. This will be our final answer. So, any questions?
Yes, me.
Caesar?
Do I have to memorize both of those formulas?
Well, it would be helpful to, because in some cases the quotient rule doesn't have to be utilized, but in some cases it can be the quicker method. But most of the time I find myself actually using the product rule in almost every single case. So the way I can show you to do that is with that same function. Let's actually go back and look at that function real quick that we took the derivative of. It was x squared plus 4 divided by x plus 5. What we can actually do with that function is we can bring this x plus 5 up to the top with x squared plus 4. All we have to do is x squared plus 4 times the quantity of x plus 5 to the negative first power. So now what we've essentially done is create a product rule.
Dude, how do you take the derivative of x plus 5 to negative first power?
That's an excellent question. See, the reason I brought us down this path is to show us our next topic and lead us into it. This is actually what we would call the chain rule. So what we would have to do, so first let's start by taking the derivative of our first function, which would be u, and we would get 2x, and then multiply it by our x plus 5 to the negative first power, and then add that to this. So what we would have to do to take the derivative of this right here, this quantity, is our chain rule. So the chain rule actually states that we would have to, so if we had f of g of x, what we would have to do is take the derivative of the outside function first, and then keep the initial inside function the same, and then multiply it by the derivative of the inside function. And now that may sound confusing the way I explained it, so let me just show you quickly as an aside how I would take the derivative of just this quantity right here. So if we had x plus 5 to the negative first, I would use essentially a variation of the power rule, and I will do -1 times our coefficient, which would be 1, and I would get -1 times x plus 5, which would be our initial inside quantity, and reduce our power by 1, which would be -1 minus 1 is -2. And then we're not finished here. What we actually have to do is multiply by the derivative of the inside function. So here it would just be 1, so it doesn't make too much of a difference because the derivative of x plus 5 is 1. But in a different function, say if this was x squared plus 5 instead of x plus 5, it would actually be, we would be multiplying by 2x out here. So, but with this one, we would just have -1 x plus 5 to the negative second power. And for this part, we're going to leave it as that. I know you cannot have a quantity to a negative power, but we will deal with that later. So let's go back to our original problem. So we already did u prime times v. Now let's do, we have our v prime down here. Let's do our v prime. -1 times x plus 5 to the negative second power times our initial u, which is x squared plus 4. So this may look a bit confusing, but really all that we have to do is take out a x plus 5 to the negative second power out of this whole quantity. So what we would do then is see that it would be 2x times, so if you took this out of here, it would be times quantity x plus 5 plus,
wait, why does it become a positive exponent?
So what happens is if you take a x plus 5 to the negative second out of a x plus 5 to the negative first, you would be subtracting them.
Oh, so you get minus a negative?
Yeah.
So it would be -1 minus -2, which is positive. Got it.
Yes. So let's continue. We would then, this would then be erased essentially because it is the same thing, but it just turns to be -1 if we would leave the coefficient. So plus -1 times our u, x squared plus 4. So what we've now done with this is we've taken the full derivative, but we have to pretty it up again as we did before. So let's move this to the bottom and simplify the top. So we would have 2x squared plus 10x plus negative x squared minus 4 over x plus 5 to the second power. So if we were to simplify this all the way out, we would then get x squared plus 10x minus 4 over x plus 5 squared. So let's check and see if this answer is the same as our first answer. Okay, so this is our answer to our quotient rule, and this is our answer to our product rule version. So as we can see, the answers are equivalent. So we have chain rule. So real quick, I just want to give the class an example and see if you guys can complete it. So let's give you guys a somewhat challenging one. We'll give you 2x times the quantity 5x squared plus 4 to the fourth power. Okay, so I'm going to do this right now while you guys are performing it, and let's see if we match up with the same answer. Alright, so I have now completed my answer. So let's compare. Frankie, what did you end up with?
80x squared times the quantity 5x squared plus 4 to the third power.
Okay, Caesar, what did you end up with?
80x squared times the quantity 5x squared plus 4 to the third power as well.
That is also what I have gotten. Good job, class. We have now done a fantastic job today. Next week we will move on to trig derivatives. And now, as a reward, Monopoly!
Yay!
Oh, Professor Nicholas, as a young boy. Oh.
Welcome to your Hold on, dog. This is hard. This is hard.
Here, I'll
Welcome to your worst nightmare. AP Calculus.
Bum bum bum.
Welcome to your worst nightmare. AP Calculus.
Now that we've covered the power rule, I want to move on to another topic, a little bit more challenging, but essentially the same concept. Who has their phone out in class?
I'm sorry. Sorry, continue.
Put it
He's
away.
a bad kid.
All right.
Send him out to
It's
Redmond.
fine. No, it's fine. It's fine. All right. A product rule.
Dude, how do you take the derivative of x plus 5 to the negative first power?
That's a good question. What we would do is take the, I don't know, have it at an 8x actually, and factor out an 8x and have x squared plus 1 times 8x.
Wouldn't it just be
But
x
it-
plus 1?
No!
Yes, dog. Yes.
It affects our next. It's an 8x cubed.
I thought that was a 2.
What?